lesson or as a review of how to find slope on a graph or using the algebraic formula. Let's start by asking what slope is. You've seen applications of it in daily life, from the skateboarder going down the rail, Jeep trying to climb the hill, and even the really fun roller coaster rides that you like to take. Let's see what else slope is called. Grade, incline, pitch, gradient, angle, slant, tilt, lean, and rise and fall are particularly used in algebra, and we'll see that application as we go to graph some lines for you. Let's start with two basics. A positive slope is a slope that rises as you go from left to right. It rises to the right, as we say. A negative slope actually falls as you move from left to right. So it's a slope pointed in a downward direction. We graph lines on the Cartesian plane, which was created by René Descartes in the 16th and 17th century. His well-known graphing coordinate system allows us to meld together geometry and algebra. Let's start by putting 2 points on a line. The first one will be at 0, -2. And our second one is going to be at 3, 2. And we'll draw a line going through those 2 points. And now let's figure out the slope of this line. We'll start at point 0, -2, 0. And we'll go over 1, 2, 3 units. That's a run of 3. And then we'll go up 1, 2, 3, 4 units for a rise of 4. And in algebraic notation, we refer to slope m as the rise over run. So in this case, it would be 4 over 3. So the slope of this line is 4/3. Let's do another one and take a look at a negative slope. Let's make our first point at 1, 3, and our second point at 4, -3. Okay, we'll draw a line down through there and take a look at the slope of this line. Starting at our first point, 1, 3, you'll see that we go down 1, 2, 3, 4, 5, 6 units. That's a -6, or a fall of 6, and then a run of 1, 2, 3 units. So our slope then would be a fall of 6 units over a run of 3. Simplify that fraction, you'll get -2 over 1, which we always write as a whole number when it's over 1, and simply have a slope of -2. So that's a case of finding the slope of two graphed lines. Let's look at two special cases. The first one is to take a perfectly horizontal line. We'll put this one through y at 3. And that's how we name this line. We say y is 3 because any point on that line has a y value of 3. You'll see that it's perfectly horizontal. So in the case of this, the slope would be 0. It's totally flat. There is no rise or run. And that's somewhat counterintuitive to say y is 3 for a horizontal line, so you really want to pay attention to that. In the second case, we're going to put a perfectly vertical line through x is negative 3. And that's how we name this line as well. All the values of x are negative 3. And we name the line x is negative 3. Notice there is no rise or run on this line either. It's perfectly vertical. So we say the slope of this is undefined. I'm not going to go into that in detail in this case. You might want to look that up. But the slope of it is considered to be undefined for a vertical line. And those are our two special cases, a perfectly horizontal line with a slope of 0 and a perfectly vertical line with an undefined slope. Now let's look at calculating the slope of a line using the algebraic formula. Slope equals y2 minus y1 divided by x2 minus x1. And we're going to use the points that we graphed for the first two lines. So we'll write those two coordinate points and label them as x1, y1, x2, y2. The first point was 0, negative 2, and 3, 2. Let's fit them into the formula. And just to review, that was y2 minus y1 over x2 minus x1. And we'll fit in. y2 is 2 minus y1, negative 2. Don't get those two negative signs confused. That's a very common mistake students make. They get the negative of the value confused with the minus sign in the operation. So let's go on. x2 is 3 and x1 is 0. That's 3 minus 0. Solving that, 2 minus a negative 2 is 4, and 3 minus 0 is 3. And as you recall, the slope of our first line was 4/3. Now let's calculate the second line that we did. The first point was 1, 3, and the second point was 4, negative 3. Fitting that into the formula, we have y2, negative 3, minus y1, which is 3, over x2, 4, minus x1, 1. 3 minus 3 is negative 6, 4 minus 1 is 3, and as you recall, the slope of that second line was negative 2. So now we've seen the slope of two lines on a graph and calculated using the slope formula. That's this overview for slope.